All right, so in this section, 8.7, we're studying radical functions. So we start off with, what does the graph of the radical function look like? So we'll start by graphing the radical function. So using the points that are provided, we have f of 0 is the square root of 0, which is 0. So the point is, your x value is 0, and f of 0 is 0. The next point is 1. F of 1 is the square root of 1, which is 1. So this is a point 1 comma 1. 4, f of 4, that's going to be the square root of 4, which is 2. So this is the point 4 comma 2. And the next one, 9, this is f of 9, which is the square root of 9, which is 3. So this would be the point 9 comma 3. So the goal of this section is that we understand what the graphs of radical functions look like. And namely, we're going to really focus our attention here on the square root function, although we should be able to identify the cube root function as well. And we should be able to perform transformations on these functions. So the base case we're going to look at here is the square root of x. So if I was going to plot these points, I would start with the point 0, 0, so this point right here. Then I would plot the point 1, 1. Then the point 4, 2. And then the point 9, 3. And so my graph looks like a part of a sideways parabola. That is the graph of f of x equals x squared. It looks something like that. And it goes on forever and ever in the x direction and in the y direction. Positive x and positive y. So that leads us to a couple of questions that I want us to examine. So you'll want to have this for reference, so you may need to flip back to it. So the first question that they want to know is, what is the domain of f of x equals square root of x? Now remember, the domain deals with the x-axis. So the domain always deals with the x-axis. And so if we look at the square root function, what that graph looked like, and I'm just going to throw that back up here. The x-axis that we use, notice we don't have any negative values of x. We do have all the positive values of x. And the word of warning here is, it looks like this graph stops at 10, but this arrow means that the graph actually goes on forever. So that means we can use all the positive x values, and we also use 0. And 0 is included because you can take the square root of 0 and you would get 0. So we would say the domain of f of x equals square root of x. That domain is x bigger than or equal to 0. And that's the notation that we'll use. You could also use interval notation, but we'll stick to this notation. So x needs to be bigger than or equal to 0. But what's the range? The range is the y-axis. So how much of the y-axis do we use? Again, you need to look back at your graph, so I'm going to put that out front for a second here. So in this graph, how much of the y-axis do we use? Well, let's look. Do we use any negatives? Doesn't look like we have any part of our graph that is below here. So we don't use negatives. So that means we have to use the positives, and certainly we can convince ourselves of that. This is all the positive y values. I don't have any negative y values, and you shouldn't, because when you take a square root, you should never get a negative value when you take a square root. It should all be positive, unless you're working with imaginary numbers, but we're not working with imaginary numbers. So you should always get positive values when you take your square root. And the lowest value that we have here is the value 0 on the y-axis. So we would say y is bigger than or equal to 0. That is our range. The x-intercept is when x equals 0. Sorry, the y-intercept is when x equals 0. So if we look at our table or our graph, doesn't matter which, x is 0. When x is 0, what is y? It's 0. So our x-intercept is, sorry, our y-intercept is 0, 0. And it just so happens in this case that if you look, when is y 0? So when is f of 0 equal to 0? Well, it actually happens at that same point, 0, 0. So it crosses the x-axis and the y-axis at the same point, that's 0, 0. So our x-intercept is the point where y equals 0. Is the function increasing or decreasing? So that's just, take a look at the function. Does it go up forever? Does it go down forever? In this case, it goes up for infinity. So we would say this graph is increasing. It keeps on going up. As far as we go out on the x, it means we're going up on the y. So we are increasing in this function. So we would say increasing. So this function is increasing. This next one is sort of a newer concept, but not too difficult. So what we're going to do is we're going to use the graph to determine whether there's a maximum or minimum value. There's other ways you could do this, but for our sake, here in algebra 2, at this point, we're just going to look at the graph. The maximum or the minimum, doesn't matter which, they're most likely going to be asking you for the y value. So we're going to assume the y value unless they ask otherwise. So unless they specifically say, what's the x value of your maximum or minimum, then we'll give an x value. Otherwise, we're just going to be concerned with the y value there. So that's the y value of the highest or lowest point, depending whether you have a maximum or minimum. So let's look at the graph of f of x equals square root of x. So this graph, we've already determined that it's an increasing function and it's going on forever. So we shouldn't be able to say there's a highest point on my graph, because if that were true, then that would mean that at some point I reach my maximum. But we just said that x can grow without bound. It goes on for infinity. So that means I have a lowest point. So we can kind of trace that all back to the point 0, 0 right here. So this is where my graph starts, and then it goes on forever. So the point 0, 0 is where my minimum is. So f of x equals square root of x has a minimum at the point 0, 0. And so what is the max or min value? They want the y value. So the y value of the minimum is 0. So this would be the value of our minimum. So the y value of the minimum is 0. So that's the basic square root function. You can get transformations, as this table shows. You could transform a square root function, but you can also transform the nth root function. And this table just goes through those different transformations. You can have a reflection in the x-axis. Stretches and shrinks occur depending on the value that's outside the square root or the radical. And then you have horizontal, vertical transformations as well, or you could have both of them occurring. So let's look at an example where they have transformed the square root function. So in this one, they transform the square root function. It says f of x equals square root of x plus 3. Notice that the 3 is underneath the radical. It's underneath the square root sign. And we're going to cross off negative 4. Because if we put negative 4, and I'll just show you this, you get square root of negative 4 plus 3, which that's the square root of negative 1, which is I. And we can't have imaginary numbers. We're not going to graph imaginary numbers, so we're just going to cross that off. We're not worried too much about imaginary numbers here. Where we wouldn't plot that on the same axis. So we would not use imaginary numbers. So we could use negative 3, though. F of negative 3 is the square root of negative 3 plus 3, which is the square root of 0, which is 0. So this is the point negative 3, comma 0. Next one, f of negative 1 is the square root of negative 1 plus 3, which is the square root of 2. And that comes out, if you put it in your calculator, you get a decimal. So 2 is not a perfect square. You get about 1.41 here. This will be the point negative 1 comma 1.41. You could plug in f of 0. The square root of 0 plus 3, that's just the square root of 3. If you did that in the calculator, you would get about 1.73. So this would be the point 0 comma 1.73. Plug in 1, f of 1 is the square root of 1 plus 3. That's the square root of 4, which is 2. So this is the point 1 comma 2. You can plug that in. F of 2 is the square root of 2 plus 3. That is the square root of 5. As a decimal, that's about 2.23. So 2 comma 2.23. Before we answer these questions below, we need to plot the points on our graph. So we'll plot the point negative 3, 0, negative 1, 1.41. Be careful with this point. This is just above the 1 on the y. 0, 1.73. 1 comma 2. And 2 comma 2.23. So this is what that graph would look like. It's just a transformation of your square root of x function. So let's compare this. What's the domain of f of x? So the domain, well, how much of the x-axis do we use? It starts over here at negative 3, and it goes on forever. So the domain is x is bigger than or equal to negative 3. It goes on forever in the positive x direction. Notice as we get bigger, as our function increases, so do our y values. Our y values never get smaller. The range, how much of the y-axis do we use? So the range here, it looks like the lowest y value you have is at 0. It's negative 3, 0, your lowest y value there, and it goes up on forever from there. So y is bigger than or equal to 0. So you always want to refer back to the graph. The max or min value, does this look like it has a max or a min? Well, this looks just like the square root of x function. There is a lowest point here, and from this point, everything goes on and gets bigger. So this lowest point is negative 3, 0. So this would be a minimum at negative 3, 0. And the value is 0. The y value is 0 at that point. Now, if they wanted the s value, they would have said, what's the x value at that point? Number 4, wants the x-intercept. Where does this thing hit the x-axis? Remember, in other words, we want to know where is y equal to 0. So look at your table for that. Or you can look at the graph. So where does this graph touch the x-axis? It touches it at this point, which is the point negative 3, 0. Or you could have got this from your table. Where is the y value 0? It's at the point negative 3, 0. Your y-intercept, again, does this hit the y-axis? If you go up, it looks like it's just under 2. So let's refer back to our table for this one. Where is x equal to 0? That's my y-intercept. So if I would go down my list looking for x equal to 0, looks like it's right here. So 0, comma 1.73, or you could be really specific with it and say the point 0, comma square root of 3. Either of those would be acceptable. So if you have any questions, please write them down and bring them with you for next class. And the video for the next section will be up shortly.